Okay, so we need to talk about the honeymoon phase of AI coding. You know exactly what I'm talking about. You open your favorite LLM, you go there in the chat window, you type the prompt, and boom. Just like that, it generates the entire code snippet, entire project, or even entire UI, UX, backend, frontend, everything for you with just a prompt. But here's where it gets interesting. So you ask for an iteration, a minor change in your UI, UX, or in the backend layer, and things get messy. You ask another change and another and another. The context window starts getting messier and your prompts are not working anymore. The code starts hallucinating. Everything will become a mess. And suddenly, what we used to call as vibe coding, the vibe suddenly dies. So you are not building software anymore at this point. You are just gambling with the prompts. You spend more time reviewing, debugging, and babysitting the AI generated code than you would have actually taken to write the code by yourself. So, this isn't engineering anymore. This is just creating AI slop and technical debt for you. And your company might have to hire someone to clear that AI generated code or to clean up that AI generated code for you. So, it is really a challenging situation that we are in today. And this is what I realized also if you have been following me. So, I recently published 30 days of AWS Terraform, which has end-to-end Terraform with AWS, plus it had 10 mini projects and 7 real-time projects. So those projects were production grade project with the best practices, with the security and everything intact, so as to mimic what we do in an actual production environment in a corporate world, right? So I tried many AI tools to have at least some code generated so that I can make some changes to it. But again, as I have told you, the context window was messier and it was just hallucinating a lot. So, for example, it did not create the production grade project as per the best practices. So, I ended up writing everything from scratch by following through the documentation. Yes, my team also helped me with that. But the issue here is it did not take into account the latest feature being introduced by the AWS Terraform provider or even with the Terraform itself. It did not take into account the production best practices such as using custom modules or using S3 built-in feature of state file lock-in. It was still using DynamoDB for state file lock-in, which has been deprecated already. And many more challenges were there. On and on, the code was not really meant to be used even for the tutorial, because when I tell you that it's a production grade project, I make sure that it is a production grade project. And this is what I was not getting. So that get me thinking, that get me into the research mode. And then I found this tool called Zenflow. Okay, I have tried it myself. I wish I had this before the beginning of the series so that I could have used it in the series itself. But I will do the same thing in this video. I will show you the end-to-end demo of how it helps you create a production grade project with the help of custom agent. So I'm going to create a Terraform custom agent that helps you generate the production grade project with the predefined workflow and with the orchestration layer that it comes with. So how it works, it's an orchestration layer that sits between your idea and your code. Okay, it helps you with the step by step systematic execution of not just writing the code but also debugging it, executing it, and also ask your suggestions, your inputs from time to time, because it's an orchestration layer. It's not just another AI prompt series of prompts, right? It doesn't work like that. AI does not need more prompts, right? It needed an orchestration layer, and this is where Zenflow comes into the picture. So how does it turns the chaos into a production grade system? It basically comes down to three things. First is workflow, not random prompts. So Zenflow uses a workflow in which you can use the inbuilt agent or you can create your own agent that helps you execute the workflow as a set of steps, and it could be an autopilot or human review that can be done before the execution so that the output is standardized every time. Second is, and this is huge, it uses model diversity. What model diversity does it? You can use Claude for one agent that actually writes the code. You can use GPT for another agent that actually reviews the code. They talk to each other so that you don't have to babysit. They verify each other to catch the blind spot and ensure that the code is ready for the production. And third is spec driven development. It ensures that your code follows set of standards, set of practices, and it acts as a disciplined engineer, not as a creative writer. I think we have covered a lot about the theory part of it, what exactly it is, how does it work. Now it's time to see that in action. So we're going to dive into the demo and we'll be creating a production grade project from scratch. So let's get into it. All right, so I'm in my GitHub repository. As you can see, here are two files only. So one is the prompt for installation and setup of agent. The other prompt is to generate the Terraform code, because what I've told you before as well is we'll be creating a custom Terraform agent that will help us generate the entire project end to end as per the best practices and as per the instructions that we provide. Also, it has to consider security while generating the code. Like, it has to be an end to end production grade project, right? So we have to provide specific instructions to the agent so that it takes everything into account and ask follow up questions whenever it needs more clarification, right? So we'll start with this prompt, which is readme, readme.md. This is the one big prompt which have a lot of details. But before that, let's just go ahead in our Visual Studio Code and install the extension for Zencoder. Okay, so I'm just gonna go to extensions over here and search for Zencoder and install this extension. Okay, as you can see, it's an AI coding agent. It has been installed. Once it is installed, you can go to Zencoder over here. If you see on the right corner of the screen, you will see a prompt which says open Zencoder. Click on that and it will open the agent over here. Now you have to configure the agent, but first you have to sign into the agent. I think I am already signed in. So let me just log out so that I can just show you from the beginning. Okay. So once you install the extension, this is the screen that you will see. It says AI coding agent that understand your code and sign up in just 1 minute. Okay. So let's hit the sign up and it will open the Zencoder homepage, the sign up page. You can do the sign up via directly from the website as well and then just log in the extension. It's one and the same thing, right? So once you do that, it will, okay, it actually it logged me in, but if you are doing for the first time, it will ask you for sign up. So you can just sign up with any email provider like Gmail, Hotmail, whatever is supported, and then you can click over here, open VS Code. So it will redirect you over here. Okay, so now I have signed in. It's doing the sign in the Visual Studio Code. I think I have cancelled the prompt, so let me just do that again. So once you go over there, and then let's allow this and hit open. Okay, I have to just allow that. Now you will see the agent prompt like this. So it says ready to build something great, and there are different things over here. What we need is an agent, right? So over here, right, as you can see, I already have a custom agent, but I want you to see and show you how do we create it from the scratch. So click over here which says manage, right? And now it will show you all the inbuilt agent and the custom agent that I have built. Now hit on create agent. That's the first step. Give this a name. Let's call it Terraform agent. Okay, and you can share it within your team or you can just keep it private to yourself. I'm going to keep it private. Give it an alias. Let's call it Terraform and give the detailed instructions over here. Now these detailed instructions can be found in that GitHub repository. I will share the link in the description, so don't worry about it. So I'm just gonna copy everything from here and paste it over here. Okay, I'll show you, I'll walk you through what this prompt is and what exactly does it have. Now it has some inbuilt tools. Okay, tools is what are the capabilities of this agent, what the agent can do and can perform on your behalf. Okay, so first is execute shell command. So it will be executing shell command, but obviously without your permission it won't do anything. It will first prompt you, okay, this is the command that I'm going to run, do you accept it, do you allow or deny? Once you hit allow, only then it will execute any command on your behalf, right? Then fetch web page content. It will parse the content from a web page. It can be treated as a file editor, file search, or full text search within the repo or outside. Then it will gather the requirement from you, like it will prompt you multiple questions and multiple clarifications for better context, run diagnostic, and it can also perform the live web search so that you always get the latest results or the latest best practices, latest features of the product that you are trying to build. Okay, so once you're satisfied with everything, you can go and hit create. And with just that, the agent has been created over here. To use the agent, you click on new chat and select the agent over here on the left side, right? So Terraform agent is something that we have created. There are some inbuilt agents, as you can see, which is code, unit test, ask, E2E test, repo info, web dev. So these are the specialized agent for the special task. Like for unit testing, if you want to just create and execute unit testing, so this is the agent that you would choose. If you want to work on coding, that code agent is something that is preferable for you. End-to-end testing, this one, web dev, this one, and so on, right? For your task, you are creating a Terraform agent. So this is what you're gonna use. So just select that. And there is the model selector. So it has multiple models inbuilt that it will be using on your behalf. So using auto will help you save some cost, like it will use the best agent as per your use case, and it will use the optimum utilization of tokens based on that, so that you won't get charged extra. And like if you want to go ahead and use any specific agent, then you can use that as well. As you can see, there are multiple Gemini agent, GPT 5.1, Grok, Sonnet 4.5, Haiku, and so on, right? So I'm just gonna keep it to auto. Okay, now over here, oh, before that, let me just show you what this prompt is. So this is the prompt that we use to generate or to set up the agent. So first is we provide the role. Okay, so your role is who you are. Like we are talking this to agent. You are a senior Terraform and DevOps architect, and you need to generate production grade security first, fully documented Terraform infrastructure and GitHub Actions CI/CD pipeline. We are also generating a CI/CD pipeline with this Terraform agent, so that it helps you with the drift detection, and it will roll back the changes, or it will reconcile the changes with whatever you have in the repository. Okay, so if you don't know what drift detection is, so let me just quickly explain it to you. Drift detection is nothing but matching your desired state with the actual state, right? So let me just quickly walk you through it. Let's say you have your AWS environment over here, right? So I'm gonna just write it down over here. So you have your AWS environment with multiple resources. You have your EC2 servers over here. You have your database. So let me just pull out the database symbol. Okay, you have your database. You have your load balancers. So let's call it Elastic Load Balancer, right? And let's me put EC2 over here for just some clarity. Okay, now let's say you have multiple resources over here. You have your database, load balancer, you have your EC2 instances. Let's say there are multiple EC2 instances, and let's also say they are part of an auto scaling group. So I'm just gonna write it down over here. This is an ASG, right? And there are database servers. So this is something that a user has created, okay, using Terraform. So let me see if they have Terraform. Yeah, Terraform logo is here. So this is something that a user has created. Like this user is a DevOps engineer or a cloud engineer, right, who's maintaining the infrastructure on your behalf or for your company. These all resources have been created and managed by Terraform. But this user, like let's say this DevOps engineer, can also go and make the changes directly over here, right, on the infrastructure, on the live environment. But you don't want to do that, right? You don't want anything that has been made or any changes that has been made on the live infrastructure, like this could be your production infrastructure. You don't want like someone go ahead and delete this EC2 instance. Like how will you find out unless there is an audit trail, unless you debug it, and it will be a lot of blame game that will be followed up with that, right? So how do we make sure that no one is allowed to make any changes directly on the infrastructure? And there should be only one. So with drift detection there is a concept called single source of truth, right? So that means there should be only one source of truth, because we are using Terraform to provision the infrastructure. Let's say Terraform code could be stored somewhere on a GitHub repo. Okay, so whenever user making the changes, they are actually cloning the GitHub repo, and that GitHub repo will have the desired state of the infrastructure, and then only the infrastructure will be provisioned. Okay, so this GitHub repo is nothing but a single source of truth. That means your DevOps engineer should not be allowed to make any changes on the infrastructure without the GitHub repo. Okay, so let me just put a cross over here. Okay, so this should not be allowed. Now, how would you prevent that? And what's the significance of it? You see, the DevOps engineer over here is making the changes. So, this, like whatever is there, this is the desired state of the infra, right? And this over here, what you see is the actual state of the infra. Now, this should be like the main purpose of using this drift detection is to make sure your desired state is equal to the actual state, right? If there is like in your single source of truth, if in your GitHub repo where your Terraform code is, it says like this auto scaling group should have two EC2 instances running all the time, like desired number of EC2 is 2. Like so the actual state should also be true. This desired state should match with the actual state. And whenever it happens, let's say someone went ahead and delete this infra, so this desired state now is not equal to actual state. So there should be a reconciler, there should be some mechanism that will roll back the changes and bring this back. So this is called drift detection. We are detecting the drift in the infrastructure. So what is the actual state? What is the desired state? If the actual and the desired state are not equal, that means there is a drift. And it has detected the drift. Now it will roll back the changes automatically. So this is called drift detection. And to enable this drift detection, what we have used, we have created a GitHub Action CI/CD pipeline. Okay. So let's go back to our prompt. So this is just to show you what a drift detection is. Here's the role. Now we provided some mandatory instructions. So mandatory is web search first, no exceptions. We are instructing the agent do the web search first before writing any code. Why? Because when we use Terraform uses Terraform providers, and these providers changes very frequently. And as you all know, like the LLMs that we use, these LLMs are trained on the data and it doesn't have the latest data. So there are high chances that it will generate the code that is deprecated or that has been changed already. And for that, we need to make sure that our agent is using the web search so that it can follow the official documentation to generate the code. So that's what we are doing. What are we saying? Stop, search the web before writing any code. Okay, and required searches are these. So Terraform CLI latest version should be December 2025. This is when I'm recording the video. Okay, and all the provider version is also latest, and the best practices and the deprecated December feature should also be taken into account while generating the code. Now verify the sources. What are the sources? Terraform.io registry, Terraform.io official provider docs, and do not rely on Stack Overflow, Reddit, or Medium without verification. So let me just make some changes so that it doesn't mess up. I'm just gonna add enter over here, right? Now document. Okay, let me go back. Okay, so this is allowed, this is not allowed. Now, document finding, web search, okay, and use the Terraform CLI version, provider version, feature implementation detail, and sources. If unclear or incomplete, stop and ask user. So we are instructing the agent to ask us for any clarification before doing anything that is not unclear or incomplete. Okay. Then response workflow will be like this, which is web search first, show result, execute 3 5 searches, document version and sources. Then ask for the requirement if missing critical info, like ask the cloud provider, regions, account ID, environment, backend config, many other details, right? Then generate the code using verified info, verify it again. So we are instructing it again and again. Mandatory standard like version management. Make sure you pin the version to a particular Terraform version and for the particular provider version. And why this is important, I have already explained this in one of the videos in the Terraform series, right? Now it also says pin version with this or bounded. Never use the latest version or floating version. This should be the repository structure. That means it should have a modules folder with multiple modules and separate files. There should be an envs folder with the environment related config. And these are all the best practices that we are instructed. And there should be a GitHub Actions folder as well for the CI/CD pipeline. Then there were some changes happened recently. I'm not sure when it happened, but I guess it happened somewhere in 2025, in which the DynamoDB has been deprecated to be used for S3 state locking. Now S3 has an inbuilt feature which can be directly used with use lock file equal to true. And this is with Terraform 1.11 plus versions. It is available, right? So we are instructing the agent to use this best practice as well. Okay, and we are saying here as well, like DynamoDB is deprecated, do not use it. Now there are some security default that we are ensuring: encryption at rest, private networking, least privilege access, no hard coded secret, and flag any public access if it is open on 000 dot for the outside public, right? Then here are the stages of CI/CD pipeline. For production, we are saying make sure there is a approval stage as well. Okay, here's the required workflow, and here are the required deliverables. So modular Terraform code, complete and production ready, environment config, GitHub action workflow, documentation for setup, placeholder commands, for security policies, for operations, version verification with sources. And these are the things that are strictly forbidden. What are these? Deprecated syntax, unverified argument, latest version, all those things, right? Here are some of the quality standards that we are ensuring. Your code must meet this, right? Here are some key principles. Here is some critical failure mode, some success criterias that we are saying, and there are few other details about the primary detective. So once you are satisfied with everything, once you have verified it, you can just go ahead and create the agent. Now the agent has been created. The next is to go through this sample.md, and it has basically a simple project instruction like write Terraform code to provision a complete AWS infrastructure with the following components. So there should be a VPC with these features like with NAT gateway, elastic IP, and so on. There should be security group that allow inbound on port 80 and 443 traffic from anywhere, like all the details that we are providing. Now create a launch template on AMI and so on details, and make sure your private S3 bucket is version enabled, server side encryption enabled, and block public access, all those things, right? So let's copy the raw file and go back in our Visual Studio Code, and in the chat, like when we open the chat, make sure your agent is selected. Just enter the prompt, hit enter, and wait for magic. Now it should ask you a lot of details, right? Let me just close this. Okay. So what it is doing, it is still doing its work. It is still thinking. It is taking into account all the things and all the agent configuration related details. And now it is now doing the web search for all the details that we have provided. Okay, so latest Terraform CLI version was released on 17 December. It has taken that into account. It has taken that latest AWS provider version as well, released on 17 December. Then S3 native locking, and then it is saying DynamoDB is no longer required. All the things, it is now doing the requirement gathering. Now it is asking, please provide these details so I can proceed with the implementation. Like all the details it is asking, because like we have instructed the agent to ask the user for any clarification or any incomplete details, right? So over here, I don't want to type and enter everything, right? So let me just ask the agent, ask me with multiple choice options, right? Okay, now I don't have to type everything. Now it is providing me different choices for each of the questions that it has. Which AWS region should we use? Let's say US East 1. Hit next. Which base operating system AMI do you prefer? Let's go ahead with Ubuntu. Hit next. What is the preferred instance type for auto scaling group? Let's go ahead with T3 small, or I can go ahead with T2 micro, right? So click over here, T2 dot micro. Hit next. How SSH actually should be handled for private instances? Let's say restrict to my current IP. Okay. Hit next. Now, what is the desired application load balancer listener configuration? Let's go ahead with 80 for now. And if you want to generate the certificate as well with ACM, you can go ahead with HTTPS. Hit next. How should GitHub Action authenticate with AWS? Right. So let's go ahead with IAM user access keys and hit submit. Once you submit it, it will check again and it will create the plan. It will ask for any clarification if it needs. But what it is doing right now it is saying I'm gonna create a directory structure for you as per the instructions provided. So here is the structure. So it will create a modules folder with VPC, security, load balancer, compute, and storage as the subfolder, three folders for environment, and rest of the details, right? And if you verify it, so here is the command. Remember, we had the tool which says execute shell command. So this is what it does. Basically generating, it is creating the directory with mkdir, and it is creating all those directories and subdirectories. So let's hit run once. Now it says command executed, and here are the logs as well if you want to see. But now it has created those, and now it is proceeding to write the code. So it is writing the code. If you go back over here, you will see that your folder structure has been created. Here are the modules, here are the envs, and here is the GitHub Action folder as well. Now it is generating the code and the module. So let me just pause the recording for a brief. Okay, now after a few minutes, it says I have generated all these files and everything, and here are the documentation as well that I have created. And it will be again here in this folder operations.md, security.md, and then there is readme.md. And it says now you can verify and if you want me to proceed, right? So now let's say, okay, let's first verify if it has few things that we wanted to make sure. Like, so let's say for dev, okay, there is nothing for dev, there is only one environment folder for prod. Let's verify all these modules. Yes, it does have files and it does have details. Okay, it does have resources. Okay, let's go ahead, and inside VPC, it has created a VPC, internet gateway, AWS subnet. There is a private subnet, elastic IP for NAT gateway, route table. There should be route table association, and yeah, so there are multiple route table and multiple route table associations. So those things are good, but I don't see anything created inside dev and test folder, and I also don't see the backend.tf for this. So there is no separate file for backend as well. So let's go back over here and let's check. Okay, so let's say execute the Terraform code step by step and ask any clarification needed. Okay, let me just, okay, now let's see what it does. Okay, and while it's doing it, let me just verify. Let's go back over here. Is there a file for the version Terraform version, I don't see it. So let's go back. And now it is doing the format check as the first step. Okay, so let's say run once Terraform format. This is the command that it is executing. Now it says command executed. Next step is to run Terraform init. However, the current configuration in prod main is set to use remote backend, which I cannot access or create. Now it is saying either switch to the local backend or mock initialization. Additionally, I need a value of AWS account ID and allow SSH, right? It is asking for further clarification. So let's do this. So just create the prerequisite infra such as S3 remote backend. Use the AWS credentials from local CLI. And what else do we need? So it says there is one for the backend, another one is it was asking the account ID, so I'm just saying use the locally authenticated AWS credentials. And the third one is, and also generate the code for dev and test as well. So even if I don't instruct it, later on when executing it, it will detect it and it will generate the code for that. But let's just go ahead with that. Okay. So after a few minutes, it says the dev environment is now successfully provisioned. Here are the ALB details. So let's copy this and let's try to open that in a new tab. Okay, it shows the default Nginx homepage. Maybe it did not configure the user script with some default homepage. That's why you are seeing that. So let's go inside the main.tf of dev environment. Let's verify that. So here are the modules for compute. So details should be there inside compute. Let's go inside modules, compute, main.tf. Okay. So here's the launch template, network interface. Okay, you see the user data script is pretty simple, straightforward, which is installing the Nginx, start and enable it. You can add the details in the agent prompt that generate a sample static website or running on Nginx, something like that, or a portfolio website or a to-do list app or anything that you want, right? So it will take that into account while generating the code as well. But for now it just created something so that you can test and verify if your infrastructure is up or not. Okay, so which is what it did. Now there is one more thing that I wanted to test is the backend details. Okay, so if we go to this file, no, dev main.tf file which has the backend details. So over here you see it is using the native feature of S3 state file locking with use log file equal to true, because this is what we have provided in the agent. Follow this, follow the latest features, don't use the deprecated feature, make sure you use the web search result, make sure you use the provider documentation, all those things. And as per that, this is supported only. Now if you try to generate the code, and I want you to try it out, if you want to generate the code and if the LLM that you are using is not trained on the latest provider data, then it will not use this feature. It will still try to create DynamoDB and the log feature of DynamoDB. Try it out and let me know in the comment if that is the case. Okay, so it has created the infrastructure. Let's just verify in the AWS as well. I'm just gonna do the quick login over here. Okay, let's go back. Load balancer we have seen, and there are two dev instances running because it might have used two instances inside. Like if you go to compute, which is here, and if you see the desired state or the desired number of replicas inside the auto scaling group, you see the desired capacity is 2. That is why you see two instances. Okay, and we have already seen load balancer is there. It is running on this particular DNS, and you can see auto scaling group as well over here, which is this one with two instances. There'll be security group created for this, which is dev sshsg and dev appsg, and there is dev albsg security group for each of those. There'll be internet gateway, there'll be VPC. So if you go and search for VPC, Okay, and click on that. So there was a default VPC, but this is the one that has been created, dev VPC, and you can verify the environment variables used in the Terraform code. So just to match if it is the same one or not. Okay, so this looks good. This looks great. Now let's go back over here. I can just destroy the infrastructure myself from the Terraform command, or I can just instruct this agent to do the same for me. Okay, destroy the dev environment. Okay, now that I have verified everything, so we can ask it to destroy the environment. Make sure you destroy the environment, otherwise it will accumulate cost for you, right? So cd into this, Terraform destroy, auto proof, looks good. Hit run once. Even I was doing the same thing, right? And it has created the separate environment specific configuration. So you need to go inside each of those environment, run and execute any command. And these all the environments also use a different state file for remote backend. So all the best practices are already incorporated in that. But I want you to now, it will take some time to execute the command and to destroy everything because there are a lot of resources. But what I want you to do is, I want you to try it out. I want you to take the prompt given in the GitHub repo, and GitHub repo link will in the description. Try to customize that prompt as per your requirement. Try to give a different prompt for generating the Terraform environment. Like what I have, instead of that, maybe create a 3-tier architecture with a front end, back end, database, with CDN, with S34 static file. Also try to create a sample website as part of the agent, and try to deploy that and see what results does it give you. Like if you are someone who just started learning Terraform, then try to understand the code before executing anything. Even if you are an experienced professional, it is always recommended to review the code, review the commands that your agents are executing, and then hit run once or run always or whatever it is there, right? So yeah, that's it from this video. I hope you found it helpful and valuable. Thank you so much and happy learning. I will see you soon.